Okay, guys, I wanted you to watch this video as a, well, kind of an introduction slash follow-up from what we did today in class. If you remember, we were working with the algebra tiles, and we were arranging them into rectangles. And from that, we were calculating the area of the rectangles and writing the expressions for that. Well, all of that was meant for you to hopefully understand what this distributive property is all about. And I'm going to talk about that today, and I'm going to circle back and relate it to what we did today in class with the distributive property concepts with the tiles. But first, you should be in your notes, the pink packet that I gave you today in class. It's the page right after the work that we did today in class, top right-hand corner, it says page 2, even though it isn't really page 2, but that's where it says. It's on the chapter 7, section 1. All right, let's just jump right into this, and we're going to do a task that I like to do anytime we start this distributive property concept. It's a very basic task, and all I want you to do is find the area of that figure right there, the entire figure that you see on your paper, and write down the work that you did to find it. And what I'd like you to do is just pause right now, pause the video right now, take a minute or two, work it out, and then we're going to talk about some possible solutions to this. Okay, typically what happens when you work this problem out, typically what I see is I see two different approaches to this problem, and it just kind of depends on how you look at the rectangle. So what I'll do is I'll acknowledge both of them. What we might have here is student number 1. Now, student number 1, when he or she looks at this figure, might look at it and see two separate rectangles and think to themselves, well, if I just found the area of rectangle 1 and the area of rectangle 2, then I could add the two together. And that would work, right? If I took rectangle 1, 3 times 5 is 15. Rectangle 2, granted there's a missing distance right here, but you guys know the properties of a rectangle that this value would just be 3 as well. So we would have 3 times 7, and that's 21, and then you add your two together, and you come up with an area of 36 square units. Some of you probably did it that way. The other approach would be to look at it like this. I'll put student number 2. All right, now student number 2 doesn't see it as two rectangles, but instead views it as one longer rectangle and just says, you know what, I'm going to find the area of this entire rectangle the way that it is. And in order to do that, again, you need length and width. You already know this dimension right here. Well, what they're going to do is they're going to take this length here, combine it with this length, and just say the length of that second side, call it length or width, it doesn't really matter, is 5 plus 7 or 12. So they're kind of looking at it from this angle. They're going to add 5 and 7 together to get 12, and then ultimately we're going to take 3 times 12. And you can see, it's no surprise that we get the same area when we do it that way. Now, either way is perfectly fine. Obviously, you get the same answer, right? But the second way sort of illustrates something that we're going to talk about a little bit more today. And if you remember from class today, the way that our expressions were written, were kind of in this format right here, where you had a number outside of parentheses with some operations inside parentheses. Okay? Before we get into that, let's go down here. We got one definition today, and that is equivalent expressions. Equivalent expressions are just kind of what they sound like. Expressions that have the same value. But beyond that, I ask you to describe what the quote distribute means. What does it mean to distribute? And I think we all would have an idea. So just jot something down there. Go ahead and pause it and jot something down. So a couple years ago, when I was introducing this lesson to a particular group, we needed to pass out notes. So I went up to a kid and I just said, "Hey, so-and-so," I can't remember his name, but I handed him a packet of papers and I said, "Hey, please distribute these to the class." And what he immediately did was he stood up, he walked around, and he gave each person in the classroom a notes packet. He didn't ask me, "What do you mean, Mr. Lex? I don't know what it means to distribute. Should I give to one person, to one group, to every person?" There was no hesitation at all. He knew exactly what I meant, as do you. You guys know what it means to distribute, all right? And you could word it, obviously, many different ways, but essentially what it means is to give out or pass out to each member of a group. To distribute means to supply evenly throughout. Every person in the group got a packet. He didn't give it to only the boys or only the girls or only his friends. He gave it to everyone, because if he didn't give it to everybody, then he did not distribute it to the class. All right, now you're probably wondering, why in the world are we spending so much time talking about this word? Well, it's going to illustrate this concept of the distributive property, okay? And looking at this table here, we're going to see what this looks like from an algebraic standpoint and then from a numerical standpoint. So for instance, the very first cell here, let's write the expression A and then in parentheses B plus C. And then in the cell to the right of that, let's put A and then in parentheses B minus C. The distributive property states that if you have a number outside of parentheses, you could distribute that number to every number inside of parentheses. For instance, this A, since this means multiplication here, and we all know this, can be distributed to the B and to the C, and we could rewrite our expression as A times B, or AB, plus A times C. These would be equivalent expressions. Likewise, over to the right, distribute the A through, you have A times B. The only thing that changes is your operation. I shouldn't say it changes, it stays subtraction, but it's different from that addition problem before. And then it would just be minus A times C. Okay, think back to what we did up here with, or what we did back here rather, with number 2. This is very similar. In this expression here, one way to look at this would be to follow the order of operations, which this person did, and just said, all right, 5 plus 7 is 12, and then I'll take 3 times 12. Or you could look at it through the lens of the distributive property, which is kind of what student number 1 did. Because if I take 3 and multiply it by 5, I'm doing what was done over here. And then I would also have to take 3 and multiply it by this other term, 7, and I'm going to get exactly what was done on the left-hand side. They are equivalent expressions by doing it that way. But that distributive property emphasizes that point. Now, the other row here would just be for numerical, or for numbers. So, for instance, like 4 times the quantity, 3 plus 2 would be the same as saying 4 times 3 plus 4 times 2. Okay? Or 4 times the quantity 3 minus 2 would be the same as 4 times 3 minus 4 times 2. Now, those, obviously, we could simplify all the way down to get a numerical response. But if there were variables involved, then you couldn't do that. Okay, so why don't you try example 4 here and simplify those two expressions. So write it out using the principle of the distributive property, and then you can ultimately simplify it down to a final numerical answer. Okay, so looking at letter A here, I called it example 4. I don't know why. It's example 1. I already lost track of the numbers here. So example 1, you have 4 times this quantity, 9 plus 5. Now, if I said follow the order of operations to do this problem, you're, of course, going to do 9 plus 5 first and then multiply that times 4. But if we're going to use the distributive property to do this, we're saying an equivalent expression to that would be to take 4 times 9 and distribute it also to 4 times 5. So ultimately, you're left with 36 plus 20, which would have a sum of 56. Okay, which goes back, if I did it with the order of operations, hold on, let me show you the arc there. The order of operations means that I would do 9 plus 5, which is 14, and then you do 4 times 14, which would also be 56. Okay? Out here to the right. It doesn't matter if the number outside parentheses is to the right or to the left. We know multiplication is commutative, so don't worry about that. If you wanted to rewrite it like this, by all means, go ahead. It doesn't mean anything different. But we're still going to distribute. So 6 times 12, 6 times 3, there's your equivalent expression. So then we're left with 72 minus 18, which will give you a difference of 54. Or, order of operations way says we could do 12 minus 3 to get 9, and then do 9 times 6, and you can see you're going to get the exact same answer, regardless. Okay, let's skip objective 2. We're actually going to talk about this in class tomorrow. Let's jump down to this objective 3, down here towards the bottom of the page. And in objective 3, this is going to circle back to what we did today in class, where you guys were arranging tiles into rectangles. So this should actually make sense to you because you've already seen this. The only difference is that the colors aren't the same as what you're used to. You were used to green, blue, and red, but that shouldn't affect it any. These green bars still have a value of x, but let's just say these yellow squares are like your blue squares today in class, and they all have a value of positive 1. Now, when you first look at this rectangle, if I said to write an expression about what you see, well, today in class, we would have worded this as 3 groups of x plus 2. Right? Because this first group here has 1 x bar along with these 2 cubes here, yellow. So it's x plus 2, and then I have the exact same thing in the 3. So I have 3 groups of x plus 2, which if I was writing this as an expression, I could write it in this format here. 3 times the quantity, x plus 2. The other task that I asked you to do today was find the area of this rectangle. And we had a brief discussion about how area means the amount of space that something covers. Well, this large rectangle right here, if I said how much space does it cover, well, it's covering 3 x's worth of space, as well as 6 singles worth of space. So the area of this rectangle, sorry, that's an equal sign, area is going to equal 3x plus 6. But think about what we just talked about with the distributive property. If I took this expression right here and distributed it 3 times x gives you 3x, 3 times 2 gives you 6. Okay, so you can see how the distributive property is connected with our activity today. And when you simplify these expressions, you're using the distributive property in order to do so. Okay, last thing that I want you to do here on this video is to complete this example 4 with the 3 parts. Now, the difference here is that I'm not going to tell you what the missing values are. You're not going to know what x is, or a is, or x in this case, they're all x's. You're not going to know what x is. So you would just simplify it as far as you possibly can. And you didn't know what x meant up here either in this example. So as far as you could take it was just to say 3x plus 6. I don't know what x is. I can't go any farther than that. All right? So pause it and do letter A, B, and C for me. Okay, almost done. Hopefully you paused it and you're staring at 3 simplified expressions. If you didn't, then shame on you. All right, here we go. So the first one, 8 times the quantity x minus 5. That means I have 8 groups of x minus 5. So imagine 8 rows, and in each row, probably should have used green, but I have one of these x bars, and then I have 5 of these are terrible squares, 5 of these red negative squares. Okay, but remember, I would have 8 groups of these, 2, 3, et cetera, et cetera, et cetera. Okay, now I'm not asking you to draw all that. That would be punishment. You don't have to do that. But when it's all said and done, when you had like all of this filled in, what you're going to be left with is 8 x's, or 8 times x, and 40 of these red squares, right? Because 8 times 5 is 40. So you could write it as 8x minus 40 since they're red. Or you could write it as 8x plus a negative 40. All right? The next one. I know it's a fraction. Doesn't matter. Same thing. We're going to distribute. 1/4 times 8, or 1/4 of 8 is 2. 1/4 of x, well, I don't know what that is, so I'm just going to write 1/4 times x, or 0.25x. Okay? And this is the first time where we've actually seen a negative term in front of the parentheses, but it doesn't matter. We know how to work with negatives. One thing I would suggest, however, is to make this x minus 3 into x plus a negative 3, just for the sake of keeping track of your signs. So when you distribute, remember you got to distribute all the way through. Negative 5 times x is just negative 5x, plus, now I have a negative 5 times a negative 3. It's a positive 15. So there is your simplified value for that expression. Okay? That's all I want you to do for today. Tomorrow when we come in, we're going to talk about objective 2, and we're going to continue to practice this stuff here. All right, guys. Hopefully you had a good night. All right, bye.